my name is Luke Dewees, and the questions I'm going to be looking at are from Chapter 17, and they ask us to determine whether or not the mixing of a pair of solutions will result in a buffer. So the first mixture that we're given is of 75 milliliters of 0.1 molarity hydrofluoric acid and 55 milliliters of 0.15 molarity sodium fluoride. So the two questions we have to ask to determine whether or not this is a buffer is, first, if it contains a weak acid and its conjugate base, or a weak base and its conjugate acid, and second, if there are significant amounts of each. So if we look at the equation for the dissociation of hydrofluoric acid in water, we see that it produces H3O+, which confirms that this is an acid, and F-, which is the conjugate base. And then if we look at the equation for the dissociation of sodium fluoride in water, we see that it also dissociates to produce F- and Na+, which is a spectator ion. So the presence of this conjugate base in both solutions meets this second criteria, that there will be significant amounts of each. And we can see that the first criteria is met simply by the presence of both the weak acid and the conjugate base. So this mixture will be a buffer. All right, so our second mixture is of 150 milliliters of 0.1 molarity hydrofluoric acid and 135 milliliters of 0.17 molarity hydrochloric acid. So we can look at the equation for the dissociation of hydrofluoric acid in water, just like we had in the last problem, and we see that it produces F- as the conjugate base. So then if we go to look at the second solution of hydrochloric acid, the immediate red flag should be that this is a strong acid, which we know because it's one of the big six strong acids. So right away, this tells us that this is not going to be a buffer because it doesn't meet this first criteria of being a weak acid in its conjugate base or weak base in its conjugate acid. And even if hydrochloric acid wasn't a strong acid, you can already tell that when this dissociates, it's not going to be producing any F- because no fluoride is present in the compound. So this is not a buffer. All right, for this next mixture, we have 165 milliliters of 0.1 molarity hydrofluoric acid again, and 135 milliliters of 0.05 molarity potassium hydroxide. So the equation for the dissociation of hydrofluoric acid in water is the same as the last two problems. We're still looking for F- as the conjugate base. So if we look to the next solution, there's another immediate red flag, which is that potassium hydroxide is a strong base. So right away, it does not satisfy this first criteria of being a weak acid and its conjugate base. And even if potassium hydroxide was a weak base, we can tell that its dissociation would not produce any F- ions because there's no fluoride present in the compound. So this, again, is not a buffer. Our fourth mixture is of 125 milliliters of 0.15 molarity methylamine and 120 milliliters of 0.25 molarity methylammonium chloride. So if we look at the equation for the dissociation of methylamine in water, we see that it produces methylammonium and hydroxide. So this hydroxide confirms that methylamine is a weak base, and methylammonium we can see is the conjugate acid. So we now can look at the equation for the dissociation of methylammonium chloride in water, and we can see that it produces a chloride ion, which will be a spectator ion, and that same methylammonium, which was produced in the first equation. So now we can look at the two criteria we need to check off, and we can see that this mixture does meet the first one of being a weak base and its conjugate acid, and it also meets the second one of having significant amounts of each, because that methylammonium is also produced in the dissociation of the second solution along with the dissociation of the first one. So this will be a buffer. And the last mixture we're given is of 150 milliliters of 0.15 molarity methylamine and 95 milliliters of 0.1 molarity hydrochloric acid. So our equation for methylamine is going to be the same as it was in the last question, and the conjugate acid that we're looking for is the same, methylammonium. But right away, an immediate red flag should be that hydrochloric acid is a strong acid. So right off the bat, this mixture does not meet the first criteria because it's not a weak base and it's conjugate acid, and the mixture is not going to be a buffer. So to summarize the problems we just went over, all 5 of them asked us to determine whether or not a pair of solutions would mix and create a buffer, and we figured this out by asking 2 questions: whether or not the mixture contains a weak acid and its conjugate base, or a weak base and its conjugate acid, and whether or not there were significant amounts of each. My name is Luke Dewees.